Hello everyone, we are the Trailblazers, and these are our team members Abby, Seth, Toby, and Thomas.
In 2018, the EPA measured greenhouse gas emissions by sector, and according to the EPA, transportation accounts for 28% of all greenhouse gas emissions globally, more than any other sector. Commercial vehicles account for more than 80% of transportation emissions, so the Trailblazers believe that by increasing bicycle participation, we can cut down on emissions and live on a healthier planet. Bicycles are among the most affordable forms of transportation, and according to researchers at Harvard University, cycling can also yield incredible health benefits. In addition, biking helps relieve traffic congestion and frees up precious parking spaces in busy urban areas. In order to better understand why more Americans don't cycle, we engage stakeholders as cyclists, and we also analyze the perspective of stakeholders as city planning organizations and park services.
Many of these organizations are taking initiatives to encourage bike commuting. For example, the city of Denver has a $7 million budget in improving the current biking trails and storage facilities. So why isn't it working? Thanks to the feedbacks from 4 of our stakeholders, Connor, Aaron, Clay, and Michaela, our team began to understand some of the issues that deter people from cycling, namely the lack of dedicated bike infrastructures for bike storage or transportation, and of course the high theft rates in the United States. In America alone, 2 million bicycles are stolen each year. Traditional bike locks haven't been improved for decades. They're bulky and they aren't user-friendly for everyday commuters. They can be hard to secure on a bike and could potentially damage the bike frames when riding.
In order to suit user needs, we designed a publicly accessible bike lock composed of 4 primary subsystems: the mounting mechanism, responsible for mounting the design onto a bike rack; the electrical subsystem, which controls the locking mechanics and electrical functions of the lock; the locking mechanism, which secures a bike in place; and finally the phone application that allows users to interact with the lock remotely. With our design, users will be able to securely store and remotely monitor their bicycle without carrying a heavy or expensive lock. On top of these advantages, users will be able to easily locate bike parking spaces from their phone, and on school campuses, students can even register and use their school IDs to easily access bike storage with a single swipe. After stress testing our final design in SOLIDWORKS to ensure its functionality, we implemented further security measures into our design. The unique safety guard for the deadbolt blocks prying tools, and motorized locking pins make for a simple yet secure lock. If all else fails, an alarm system can be triggered by vibration sensors. With these measures in place, the mounting and locking mechanisms cannot be easily broken by common attacks. Our final price estimate landed at around $160 for the entire bike lock, and though this number may seem high, based on similar services like parking meters, which cost up to $1,500 per unit, this price is actually fairly low. By charging users a small fee, investors in these bike locks will be able to pay off the cost of the lock over time, and even turn a profit.